Hope you all can see my screen now. Hey, am I audible? Okay. Actually, let's get started with, yeah, this talk is going to get started with Git. Yeah, before we even get there, right, let's actually look at control. How many of you are aware of version control? Like, can I see a show of hands? Okay. Where would you use it? Could you be a bit more louder? I can't hear you. With multiple people. Awesome. So that's actually a great example. So when you want to collaborate on your projects with different sets of people, you'll come across multiple problems. So just think of version control as like a save point in a video game. If you've ever played a video game, where you essentially, if you make a mistake or fail a mission, you don't start from the first level, but you essentially go to your nearest save point. So that's pretty much how version control is. So let's see what life before version control was. This was at least my life before version control. Was doing projects in college. So it used to always start with like a project draft.zip, and then there used to be like project final, and then you have final v2, and then you have project real final, like this one sort of a situation, right? Now, how do you manage all of these? So that's essentially one of the problems which you can solve through version control. One other thing that used to happen was, you used to keep trying something, and then now you don't have version control. You delete some block of code saying it's not working anyway, but now you don't know why you deleted it 3 days down the line, right? So that's the other challenge. And then, like, let's say you're working in a group, someone breaks a code, and then you're like, okay, who did this? And you're not able to trace back to, why this even happened in the first place. So yeah, let me give you a brief history of version control, right? So it was not all, well sorted out or, well put together to begin with. So there was this thing called source code control system or revision, where it was all saved on your local, like, not when you see local machine, but then you have to think about mainframes and terminals. So the terminals were dumb terminals, and then people used to lock files when they were editing it so that nobody else could write. Now then, in the 90s and the 2000s, you had something called a subversion control, and also buffers. So this is more of a centralized thing where you host all of your code in a centralized server, which would be your server. Went down, you pretty much couldn't do anything. That was essentially how it is at that point in time. And then we came to distributed version. So the reason why it's distributed is because you essentially have a copy of the entire code base in a machine, right? So there are more variants of it when you get to monocores and GitFS extensions, which we talk about maybe in a follow-on video. But why did we need Git? So the problems with SVN always existed. It was centralized server. You still had the same problem of, everybody pushing code. Basically, how it used to work was you essentially downloaded or checked out just one file from the server, and then you committed back only that file. So that was how SVN was working. And then Linux, which is an open source project, something called BitKeeper, which is another version control software. And their licensing had some issues, and essentially they terminated their license with BitKeeper. So they kind of get ground up in a matter of few weeks. So what this is it's essentially distributed. So you don't just borrow files, right? So you can essentially clone the entire project, and you get to see what all changed in terms of the history. So I will get to we'll get to more about these terms, down the line in this talk. But and the second one is like everybody has a full copy, right? So you essentially don't, if let us say the server goes down, you still have your copy. You don't really worry about, you can always have a restore point where you restore the server, but you also have your work locally. So this is essentially the basics of it. And also feel free to interrupt me and ask any questions or anything that you want to talk about. We'll get to more hands-on stuff, but let's get to some of the basics. Okay, before that, show of hands. How many of you have worked with Git so far? Awesome. Nice, nice. So yeah, I think that's a good number actually. Yep, this is nice. So yeah, what's a repo? Can one of you who has worked on Git tell me about it? Of course, it's right there, but what's your understanding of it? Anyone? All right, that's a good answer. Yep, yep. Um, and a branch. Have you used branches? Have you worked on branches so far, or everybody is just committing to the main branch? Could you be a bit more louder? I can't hear you from there. Okay, it's one copy. Um, Good, but it's, I would put it as, yeah, you can call it that. But I would basically think of more that as a clone. But it's not just one copy, but it's a parallel version of the history, right? So what you end up doing is when you have so let's actually take a repo, right? So a repo is essentially where all your files are done. Now you can have something called as a history, which will say that person X made change Y and then person A made change B. Now there can be another branch where you might have person X made change Y, but then the next change will not be person A made change B, but it will be like person C made change D. So it's an alternate history of you know the timeline. You can think of it like a parallel universe sort of a situation. But yeah, that's the branch concept. So what is a commit? So commit is again a save point. So let's say you made changes to 10 different files, right? And you were incrementally adding multiple features in those files. Now, whenever you make a change, you want to make sure that if that change doesn't most recent version that was working, V2 final, whatever, right? If I want to go one step back, maybe V1 final or whatever it was, but that's your entire repo. But the commit itself can be very much more incremental, where you can essentially say even a one line change can be added to the repo. That's a save point. So you can revert back to know that it's working. Any show of hands or anyone who wants to give a shot at what pull request is? Suggestion for a change. That's a good answer. How would you how would you look at a suggestion for a change? Like, would you make the change and then you would say that it's is it a suggestion or a proposal? Yeah. So when you say a suggestion, it could be a comment. It could be a comment in the repo itself, right, or in the pull request. So that would be a suggestion. So that's where I want to yeah. Anybody else wants to take a shot at it? Go for it. Yeah, that's very well put. So you want essentially your changes to be merged into the the branch where everybody is actually using. So essentially, you want your change to go in so that it's essentially getting used, right? That's essentially what you would want to do. So where you want to merge your code changes. Yeah, that's definitely very well put, I would say. Okay, so uh, I'll also cover something called as fork. So there are differences between fork and a clone. A clone is where you essentially just make an actual copy of it on your local system, right? A fork is where you have a repository that is hosted somewhere, and there's some owner who's managing that repository. You want to make a personal copy of it and host it yourself. That is what is called as a fork, right? So when we initially said that Git was distributed, what we essentially mean is there can be multiple people hosting the same project, but you might have different forks, right? And then there can be different people cloning from different forks or from the main, uh, you know, host itself, right? So that is what a fork is. You can think of it as yeah. So yeah, I think that's about the Git basics. Set up Git. I don't know on your machine. Show of hands. You have um, or 5 minutes to install. Then I'll also just there are multiple ways of doing it, which is what I want to focus more on. But so if you just go to this URL slash PES get install, but just bear with me for instructions to get installed locally. Do you guys need more time with the installation or? All right. Take your time. You had a question? Sorry, I can't hear you. So when you have so Git Bash is more of like a shell environment. So if you're looking for like the actual Git binary, is that a Windows machine or are you running it on a Linux VM? Windows machine. I need to see where the install path is. Just give me 1 second. Uh, Let me actually just come. All right. Do you guys need more time? Or are we good? We're good? Okay. Cool. So there are a few things if you're installing it for the first time, you would want to essentially configure your username and email. So what this is whenever you commit and you push the changes, that will be essentially annotated to your name and your email, which you can see even in the GitHub UI. So before I actually move on to the next steps, right? Can anybody explain what's the difference between Git and GitHub? Go for it. Go for it.
Hello.
Yeah, go for it.
Git is locally used and GitHub is appears very more of the documents.
GitHub is okay. Okay. Uh, that's a good answer. Go for it.
Is it also like Python is to VS Code? Like Python is a bit, the VS Code is very hosted.
You can think of it that way. So anybody else want to give it a shot before I actually go for it?
Okay.
Okay. Awesome. Awesome. Bang on. Anybody else? Yeah, I think like I mentioned, we haven't essentially Git server instances. So what you're essentially doing is when, let us say, you want to host code that other people can download, you use a Git repo or a local machine, right, using the Git application. So Git is essentially just an application that allows you to do version control. and hosting that is essentially what you do on a server, which you have like GitHub, GitLab, Bitbucket, and so many more hosting services are there today. You also have like which is I believe from Google, I guess. Yeah, you have quite a few of them. You can host your code, which you host your own Git server, absolutely. It's just that if you want all the awesome features of having like UI and manager and the main thing which is essentially data redundancy in terms of making sure that if your server goes down, nobody is able to work on the code or essentially maintain your code. So all of that is essentially what these hosting services, GitLab, they manage at the end of the day. So what you essentially do is your Git application can interact locally. You can interact with it locally. You can code, and then you push all your changes to a GitHub server. So or any code host, you can push it to a Bitbucket server. You can push it to a GitLab server. Right. So yeah, great work on getting that right. Awesome. All right. Um, yeah. So yeah, if you haven't configured your username and email, I would suggest you start with that. And then you can use URL, essentially tinyurl.com/pes-git-ssh. Again, this is optional. I'll tell you why this is optional because so there are two ways of authenticating with GitHub, which is essentially where you want to push your code to or pull your code from, right? So let me actually just open that up. Um, yeah. So what is SSH? Anybody has an idea of what SSH is? Anybody wants to give a shot?
You have to screenshot it.
Oh, yeah. So what SSH essentially is a way for you to connect to a remote computer. Put it directly. So it's essentially a secure shell. And is a very commonly used industry. So because it's essentially cryptography that is being employed here, and you essentially can access the server only if you have your keys and your registers with the server. So I'm not going to go into too much into detail about this. It's here for you to try it out. If you know want to set up SSH. So all the steps are essentially documented well here in terms of how you need to do it. So you can essentially generate a new SSH key using whatever SSH tool that you have on your operating system, because it varies from OS to OS. And you can essentially add SSH key into GitHub. I can give you mine. Let me see if I can open up mine. So what you essentially do is okay, it's gonna take some time to load, I guess, but bear with me for it. So, like I said, because this is ACI directory, what you do is you generate a private key on your local machine, and of course, generate a public key, which is the key pair. Now, only you need, so you essentially store that in your local machine, which you from, and then you share public key to GitHub, whatever your Git server is. So if you look at it, I have like, okay, yeah. So if you have, like two keys. So this is actually for my personal laptop. This is from my work laptop. So you can essentially build that or establish that chain of trust by just saying that, yeah, I trust this device, and if this key is loaded, then authenticate with GitHub, right? So also, if you guys want to try it out now, we can spend some time on it, or we try it. How do you want to? You want to try it out? Right. Do you want me to walk you through the steps, or okay? Okay. My team, right? So let's just go through one by one, right? So what do they say? Is you need to check this thing is essential. So if you go, so all of you have a GitHub account. All right. So when you go to GitHub, if you go into your profile, you can see that there is this SSH and GPG keys that are present here. So when you essentially have this, when you come here, you can just go to new SSH key. But before you even do that, you need to first generate a key pair. Now this will vary based of which machine you are working. But since I'm on a Mac, essentially these would be the that I would run. So what I do is I'm just gonna take this and I'm gonna run it on my machine. Let me go to actually go to one more. So here I just changed this your name at example.com or your email at example.com to my actual email. Right. So what this essentially generates the public and private key pair. Right. So if you're doing this on, you would essentially go actually do this on Git batch directly. If you have Git batch, then you can do it directly. You use PowerShell is another way to do it. See, do it with PowerShell. Yeah, they haven't given the steps to do it with PowerShell, but I'll try to figure out it. If you already have Git batch, then this is the easiest way to go about it. Right? So we all can follow along. So when I do this, ask me for file where I save this. Search folder so that now I just say move PES test to .ssh. It's just me. This is not needed actually, and I'll also move my option. Are you guys following along, or are there any questions? If you have a question, go for it. Yeah.
can connect to this hotspot.
Oh, okay.
And apparently you left the meeting.
Oh, okay. It's my internet, I guess.
So
Just give
connect
me
out to
one.
this. Connect out to this.
Okay.
Megamind 9134.
Why am I not able to see that? We tried it that time.
Other networks? That one. Megamind 9134.
Okay.
Password is nothing one.
Oh, I'm not able to connect it.
Try move. Oh, okay. Sure. Wait, try again. Megamind 913. Where is it gone?
Is that access point far away?
Oh, no, it's here only. This is his laptop.
Oh,
It looks like you're in the meeting now, anyways. So
all right. Yeah, I'm not sure.
it's fine. It's fine.
All right. Okay. Cool. Yeah. Sorry, you were having a question about. You had it up. Oh yeah. So what's a private key and a public key, right? So, how many of you are aware of like symmetric cryptography and asymmetric cryptography?
Screen share.
Oh yeah.
Thank you.
So okay. So when we talk about public and private keys, right? So let's say I want to send a message to you, right? I'm going to use maybe like a code that I would essentially encrypt that message with, right? So what I would do is essentially give that code to you beforehand, and I'm going to basically encrypt my message and then share it with you. Now you know the code already, and then you're able to decrypt and uh, you know uh, read the message. So this is symmetric, where you need to work on the basis of pre-shared keys, where there's only one key which is used to both encrypt and decrypt. In an asymmetric cryptography, what happens is there will be two keys essentially. One is called as a public key, and another is called as a private key. So what ends up happening is I can encrypt with my private key, and then you can decrypt with my public key. So how that works essentially is it basically what you're doing here in asymmetric cryptography is also verifying that I am the person who sent it, because only I hold that private key. I won't share it with anybody else, right? That's the whole goal behind the asymmetric cryptography. So here, what we are doing is we've generated our public key at the moment. Now, what we're going to do is we need to essentially go and provide this to the GitHub server so that you can authenticate it. Now, let's see how to do that, right? Sorry? No, so when you ran this, when we ran this SSH keygen command, it generates the key pair. So when you learn about something like RSA, right? RSA is the algorithm key and a private key, right? So when you look cryptography works, but the whole idea is like you don't have to pre-share the key, right? You can openly share a public key and still be sure that only you will be allowed to authenticate, because only you have the private key and only you can essentially send the message which they can decrypt, right? That's the whole objective of asymmetric cryptography, right? So now here, what we are going to do is essentially we have the public key and the private. Let me open this. One moment. Let's see. Yeah. We essentially generated the key, right? So we have this dot. That is what we need. So what I'm going to do is I'm going to just open that /keys-test. I'm just going to open it in VS Code for the time being. So this is my public key, right? This is what was generated. Now all I need to do is and say key. Following along, you can essentially and add a new Sorry? I didn't get it. To generate the SSH key. Okay, so in order to generate the SSH key, you need to use this one, which is key to followed by an email. Now, is already available. What you can do is go to PES. If you you'll be able to find this resume. You just copy paste. Sorry? Yeah. Okay. Yeah. So this part here, if you just go here, sorry, would you be able to? Can't we just directly? Yeah, you can. So there are two. See, when you're basically working on the Git bash on your local machine, right? You're essentially committing code to your local machine, which is fine. But now, if you want to push your code or pull code from a remote machine, like the GitHub server where we have hosted our exercise report today, there are two ways of doing it. One is basic auth, where you essentially, which is HTTPS. So how that works essentially is when you say git clone and then you give a HTTPS URL, it actually asks you to sign in using your email and password, right? That is one way to do it. The other way is SSH. So with HTTPS, you essentially need to do that for every command. With SSH, once you authenticate, that session is active. And once you essentially log in with SSH for the lifetime of your machine, like as long as your machine is turned on, you can work without any hassle. Like you can just run your git commands and it will work. So both ways are fine. Like you, as long as whatever works for you is the best one. But if you are regularly going to be using Git, which you will if you essentially commit a lot of code, then it's good to set up SSH. And this is how most companies operate. Like if you can still, say, no, I'm going to use HTTPS to authenticate with GitHub. But most companies usually recommend using SSH so that it's easier. Are we set up now? Were you able to generate your keys? Okay. So if you're able to generate your keys, what you need to do is you can just copy this, the public key. When you go here, so you can just name your key anything. So I'm just going to name it as PES test. And then I'm going to say authentication key. And then let's just add it. Yeah, so it will require me to use my pass key because I'm adding a new SSH key at the moment. Okay. Any questions, any concerns, anybody running into trouble setting it up? Go for it.
Yeah. Whatever that got generated in the Git bash, instead of in the GitHub set. Right? So it is supposed to be out and publicly and private.
Yeah.
I still can't understand what private and public key are doing.
Yeah. See, so the public key is what you give to the GitHub server. The private key is something that you should never share, right? That's why we password protect it. So it asks. So when generating the, it asked me for a password. I didn't give it a password, but you can give it a password as well. So that you try to use that private key, you first need to enter a password for you to be able to decrypt that private key. Now, why do we need to have a key there? Is because, let us say I want to clone a repo or I want to push files to a repository. GitHub. How does GitHub verify? Like, how does it know that I am the person? So there are two ways, right? One is HTTPS. So with HTTPS, what ends up happening is called as basic authorization. So what happens is it actually takes me to a login screen, or it asks me for my username and password of GitHub within the terminal, right? Now that's one way to authenticate. Another way is where we use asymmetric cryptography, which is essentially where you use a key pair. Now the public key is something that can be used to only decrypt. The private key can be used to only encrypt. But the funny part is, or not the funny part, but that's the whole charm here is essentially that whatever you encrypt with a private key can only be decrypted by its corresponding public key pair. So let us say if I just pass it, if I try to decrypt any string with that public key, it won't work. Which means if I hold the private key and if I send a message to GitHub, if it's able to decrypt it with my public key I pre-registered, then it knows that I am the one sending that message because nobody else has that private key for it to be able to for them to be able to use and send it to GitHub. You don't need to enter it. We get the next step of the daemon on your system will automatically read. Yeah. So I'm not sure to you, but like it's never a good thing to your private key, especially. But yeah, I'm gonna delete that directly anyway, so that's okay. So let me just open that. Yeah, this is how private key looks like. It's again an encoded string, which is essentially supposed to be. This is used for is basically to encrypt a message. You can use it for two purposes. One is encryption, the other one is sign. So here we essentially sign a payload saying that hey, this is me, and prove that you decrypt with whatever I gave you earlier, and every message that you know system sends, it's going to use this private key. GitHub server will decrypt it using my public key, and then it'll be like, yeah, I got the message. It's all good. It's verified that you are the person who is sending it. So it's essentially just a way for you to authenticate with the backend. I think you had another question. You had another question. You had a question.
How do you generate a private key or what is your understand how do you generate the
Were you able to follow along these steps? Okay, so did you get to the step where it asked you like a name for the file?
yeah.
Okay, name or automatically generated as ID underscore whatever algorithm. You've gotten to a stage where you've generated. Now let's ask, so if you do this, to that one, so if you can just, right. So let's just try it. Just try this. So can you see the command that I've typed? ls pipe grep star.com.
Yes, yes.
Are you able to get anything there?
No, I'm not able to get it out.
Okay, I'll just continue. So one thing that I just noticed on Windows, if you have Git Bash, it seems to be adding the key directly into your .ssh directory in your. And so it'll be like c/user/ your username followed by .ssh. That's where you'll have it. Sorry, could you be a bit more louder? Huh? Okay, it added it, right? Yeah, so that should be fine. But now were you able to open that .pub file, the public key, and add it into you were able to do that, right? Now, next step essentially is for you to so once it, right? So once you add it, then you need to essentially test your S. So how do we do that? Let's try this. So when you do essentially test, you just not just for Windows, for Mac. So if you've already done this, you don't worry about it. But you also need to do another step, which is essentially SSH add. So you need to essentially do this in your. It's something that you need to do if you're only on like a different machine where you need to add it to a keychain, right? So PES test. So it says identity added. Right? Now, what you need to do if you're on Windows, essentially try this. Right? So SSH -T git add git. So if I actually took my username and said, "Hey, I'm successfully authenticated." Right? Are you guys able to get the same thing? Yeah. So yeah, public key is added into the GitHub portal. Now here to SSH my and then git at github.com. So what you're doing is you added your private key local. You are essentially testing your connection to SSH. Saying use my private key and try to get to GitHub. Right? So that this is the sorry.
How do I key to GitHub? SSH, yeah.
Oh yeah. So you have your public key, right? When you got your public key, right? Are you able to see your public key on your machine? Okay. Okay. Yeah. Uh, yeah. Right. Yeah. So settings will be able to find it. So if setting, this will come to your profile. Here you need to access it. Okay. Here, when you click on new SSH key on the right here, you're able to see this part. Okay. So just click on it, and it will take you to a place where you can name it something, and then you can copy paste this Need any help with setting SSH or your setup? Good. Yeah. 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 So that's the whole point. So every time, so when once you're essentially authenticated, you don't have to log in every time. That's the whole point.
Directly you open.
Yeah, no. See, your GitHub UI on your browser will still need authentication. What you're essentially doing is, so SSH is another protocol. See, HTTPS is one protocol. SSH is another protocol, right? For SSH, you are already having the key that is like that. Like think of it as your password when you enter it to a file. You build SSH, the SSH client. Every time to GitHub.com, use the password. Right? Imagine if you could tell Chrome, like you use saved passwords, right? When you use saved passwords in Chrome, what it does is essentially a similar thing. Every time you go to GitHub.com, it knows what password to send. Yeah. Sorry.
If you are setting up a pass, then you need to re-authenticate every time.
No, so if you set up a pass key, right, for adding SSH, when you add the SSH key, it would have asked you to authenticate. Right? When you set up a pass key and you want to enter it, you want to enter GitHub through the web UI, right? Like on your browser, only then you need to authenticate using your here you need to use your SSH. And until you delete your public key in GitHub, you can always authenticate from this machine. Okay, I think we've spent a lot of time setting up SSH. Let's dive into the actual. So now if you go to this URL, which is essentially the tiny URL git basics PES, are you able to access this? This should take. Are you able to access this repo? Yeah, let me show you. You can just go to, yeah, I mean, you can also just type github.com/gitbasicsps, even that will work. Any folks able to access this? Okay. Let's do one thing. So let's first start. How many of you are aware of README files? So, yeah, can one of you tell me what it is? Go for it. Go for it.
Basically, the description and the context which are within the report.
Awesome. Yeah, yeah. And why? Anybody aware of what Markdown is? Okay. So, yeah, go for it. Yeah. Okay. That's actually good. Yeah, that's a great way to put it. So it's essentially formatting of text. Right? So before the days of README, I don't know how many of you have installed applications on Windows using like a zip file and then an installer and stuff like that. Right. It used to have like a readme.txt if you have seen. Right. So the txt is just plain text. Markdown is with formatting. That's essentially what it is. So you can essentially say this is H1, this is H2. Yeah, it's essentially like markup, but it's much more simpler. So markup is HTML, where you use HTML tags. Right? So that's good. Awesome. Awesome. Now let's start with forking this repo. So because this is my repo, I can't fork it myself. So what you need to do is if you come here, I mean, I might be able, I don't know, let me try forking repo. But, so if you come here, you can essentially fork this into your own, because it's already a copy, so I might not be able to fork it again. Let me just give it, let's see what happens. Okay, so here if I can't use my own name, and yeah, I don't want to choose anything that's my company at the moment because I don't want this to go there. But if you have accounts, then you can basically fork it into any of the accounts, right? So when you click on fork, you can choose if you already have, if you only have one account, then it'll automatically default that. And then you can just say create a fork. Here you can essentially say copy the main branch only, or you can essentially say if you uncheck this, it's going to copy everything. I would urge you to copy all the branches because some of the exercises require you to have the branches. Are you able to fork? Anybody facing any trouble forking? All good? Okay. Yeah. So now that you have forked your repo, let's clone it. So what is a clone? The fork is essentially where you made a copy of this Git Basics PES into your own account. Right now, you are hosting one version of Git Basics PES in your account, right? So if you go to your version, like don't go to the A05 Git Basics PES, but just go to your version of Git Basics PES that you just, and here, if you code, you can just copy the SSH version. So this is where you actually have three ways of authenticating that I mentioned earlier, right? So you have HTTP, SSH, and then GitHub CLI. GitHub CLI also allows you to log in, but again, HTTPS also requires you to log in. SSH, you've already added your private key. So if you open Git and if you just copy this, and I'm just gonna, clone it just for the sake of it one more time. So let me just see which location I'm in. Okay, so the code, right? So let me just go to ENG directly. Okay, I'm just going to make another copy of it here. So I'm just going to paste the same thing. So here, so this is actually just the URL. So let me actually just right. I need to copy the git clone command. So what I do is I essentially say copy. Okay, so let's go here. Clone the repo URL. It's kind of time given that my network is slow. Yeah, it's going to yeah. Look. Yeah, go. Could you be a bit more loud?
Could you explain again what we did after we created the fork?
Yeah, so once you create the fork, right? So what we are essentially doing is, so the fork is essentially, you can start working on this repo directly by creating a new branch. But now, like, you want to maintain your copy and you want to try all stuff. You can later also upstream the changes back into this version of the repo. Right. So when you create a fork, what you're doing is you're basically maintaining two copies in GitHub itself. One is my copy, one is your copy. Right. Now when you fork it, basically what it will what it will show is this is forked off of A05 GitHub basics PES or Git basics PES. So that's essentially your copy which you are working on. So the reason why I want all of you to fork and work on it is so that when you try some of these exercises where you're supposed to push and raise a pull request, I want to try that within that exercise. So those exercises are designed so that it can run in your own copy. But again, on this version as well, this is the origin or the main version of the repo, right? So we can try it here as well, but you just need to create a new branch and then simulate all those changes. But a lot of that is ready-made for you here, which is why I want all of you to fork. And once you fork, what you need to do is you need to clone your forked version. Don't clone the A05 Git Basics PES, but you have your username / Git Basics PES. That's the one that you need to clone. Yeah.
So if the URL at the top says my username, then I'm good.
Yeah. He has a question. Yeah, you also.
Do we clone it via HTTPS or SSH?
You clone it via SSH if you have set up SSH. So if you set up, so we just set up SSH a lot of us at time. But if you have not set up SSH, you can clone it via HTTPS as well.
Permission denied and publicly after that.
Oh yeah. So can you do the SSH command? So can you run this? But yeah, this path is going to be your SSH folder path, wherever your .ssh folder path, followed by your SSH private. You can do that. If you cd into SSH directly and say SSH-add, it should work. Let me know if it works, or else we can troubleshoot it as well. So my repo is cloned. Were you able to clone your own versions of your repos? Awesome. Okay. And, were you able to get the SSH added? You're still getting an issue? I'll just come. Anybody else facing issues with getting that kid? Or are we good to go? Okay. Let's actually let's deep dive into the session itself. So now once you have you can open that folder in VS Code or wherever you want. You technically don't need internet anymore for the next couple of exercises, but let's get started with the first one. my screen, yeah, it turned off. Okay. So we came to this readme. Let's actually look at it. Okay. So what is something that we already spoke about. Right? Now let's look at what are the possible options for that. Um, Anybody need any help with cloning so far, or are we on this? Yeah, so if you're using Git bash, use the path which is actually, so can you just EWD and you'll get the action for your .ss or wherever. So always follow that specific path. So whatever you type in the Explorer, right, like that file path is different from the file path structure that is used in the terminal. So, your own location will have a .sh folder, right? So add that folder that path, and then add your whatever thing that you are. So this is when you are trying to authenticate with SSH, is it? When you do SSH add, yeah. So when you want to do SSH add, right? So yeah, I have a but yeah, if anybody has a Windows laptop, we can just connect it here and then I can show it to all of you how that will work. Maybe you can come up here. We can connect your laptop here and then we can fix it. Just going to disconnect this for one moment. But can we just plug yours into the HTML?
I think I'm not able to copy it.
Yeah. So let's look at this. So what's your oh, okay. So I think this is actually a different problem, right? So what you're it's not showing up. Have I connected it to the wrong way? No, this is HTML. Is there anything else that I need to do with it?
Yeah, it's not projecting. Is it the wrong? I mean, this is the right one.
Yeah. Okay, let me just try it one more time.
Turn on screen sharing here. Do you know where you can see screen sharing or any
Project option is here.
Usually
a project option.
Yeah.
There. But then, which one?
Okay, you can just duplicate it. That's not a challenge.
Does it usually get read by HTML?
See?
Does the laptop get read by HTML usually?
Yeah, I've not used it.
Oh.
I haven't ever projected it.
Okay, 1 second. I'll see if I can read on laptop.
That's fine. Yeah. But yeah, I think in your case, the problem is something different, right? You've just copied the path.
Yeah.
But you need to do git clone. Git clone. Okay.
Another thing is there any other path other than using SSH?
You can use like regular HTTPS, and by the way, you're essentially trying to clone my own repo. Like, do you want to fork it first?
I forked it.
No, it's not fork. Like, this is my repo. Oh, it's already. Do you already have a fork?
Yeah, I remember forking it. At that time, I don't.
Yeah, you need to essentially use this thing. Just copy this. This is copy. Oh, no. Use this paste.
No, you can't paste in. I wasn't letting me paste earlier.
Yeah. So see, this is basically the HTTPS version. Let's use the SSH version. So you've set up SSH, right?
Yes.
Yep. All set up.
That's it? Okay.
Yeah.
Thank you.
Anybody else facing trouble with cloning of the repository? We're all good, right?
Do you want a Windows laptop? We have one ready.
No, that's okay. I think it should be good. I think. Yeah.
Yeah.
Yeah. So yeah, go ahead. It's not visible in the file manager. No, it should be. So can you see where you've cloned it into? Can you just type pwd? Wherever you type the git clone command, if you look at that directory, you'll get to know the full path of that directory. Are you able to see it? Oh, good. Okay, now that we have it, let's actually open the first command, which is essentially the git branching operations. Let's try to run through these. These are very small ones that are going to be just theoretical before we get to the exercises, right? So there are going to be 4 exercises which I want to run through and complete. Hopefully we should be able to do it soon. Now let's talk about checkout. So let's say you want to create a new branch, right? You're working on a feature, you need to create a new branch. Then you can use git checkout -b. So -b is the flag that you will use to essentially create a new branch. But before you even do that, can you just type git branch on your repository? Let me actually just close this one. And here, let me just clear the screen so that it's neat and clear. So I'm just going to say, are you able to see, how many branches do you see there? So how many lines do you see there in your response? Main purpose of creating a branch, right? Yeah. So let us say you want to work on something, like let us say, let's take an example of, some university project that you're doing at the moment, right? So you are writing a web app where your front end has like 5 different features. So you are a team of 5 people. One person will say, I'm going to take the login screen. Another person is going to say, I'm going to take the home screen. And 3 other people will build different components within that home screen, right? Now, all of you can work on the same branch, but then what will end up happening is when you need to integrate and test them, it's going to be a nightmare, because even though you're actually having version control, while you're making some change, somebody else is making another change in the same branch, right? It might be even within the same file, right? You want to test your changes in isolation, and then before you merge it into the main branch, then you pull whatever the main branch is into your branch, test it fully with the integration, and then merge it back into the main branch. So that's the whole idea behind using branches. So how branching works is, let us say, so it's like a history or a timeline, right? So it's essentially a tree. So how Git underlying works is essentially a tree. So you have like your root, or when you start with whatever the first commit you have is like your root, right? And then you keep going. So your main becomes the trunk, which is basically the trunk of the tree. So that's what they call as a trunk as well. Like literally, it's what it is, right? And then when you say you want to create one branch, what ends up happening is you basically move away from the. So let's say this is the main branch, and then you create, let us say, your feature branch, right? So you're essentially changing the history or the timeline. So the main will keep progressing in its own path now, and then you're progressing in its own path. Now, when you do a merge, what ends up happening is what all your changes come back and fall into the main branch. So it's technically a tree, right? So you can have like 6 different branches doing 6 different things, and all of them can converge and merge into the main branch. Some of them might not merge; they might just go stale, and then they are just there, sort of a situation. So that's essentially why we need branching, and how that branching works. And underneath is effectively trees, so it's a tree data structure, you can say. All right. All right. So are you able to see at least 3 branches in your git branch command? You're only able to see main. Okay. So what you need to do in this case is, so actually when you fork the repo, all branches were not copied, right, from the fork. So what you can potentially do is, so now I'm going to show you one example here. So we can just say git remote minus v. So you have your origin. So what does git remote? So I'm going to introduce you to the concept of remotes here. So a remote is essentially where, so when you clone a repo, wherever you pull your code from is one of the remotes. But you can have multiple remotes. So when you do git remote minus v, what does it show? You're supposed to see one fetch and one push. Okay, so you would have origin. What does your origin say? So it's your fork of it is your origin. And what is the other one? Is it upstream? Okay. What does your upstream say? Okay. So now if you look at it, for me, this is my origin because I've directly cloned from my own brand, my own copy. For you, what ends up happening is, because you've cloned a fork, your fork will become your origin. And from the part from where that fork was pulled into is actually upstream, right? This is particularly very, very important for open source, because when you fork a repository, certain open source projects have a license requirement for you to upstream your changes back into the original repository. So that is the whole idea behind upstream, where when you essentially make changes, you need to contribute back to the open source so that others can also start using it, right? So that's essentially called upstreaming your changes, right? Now, so for the purpose of this exercise, you will still need the other 2 branches, which is essentially important changes and John Doe's location. All right. So what you can do is you can run this command called git fetch upstream. For me, it won't work because there's no upstream remote for me. But you can try running git fetch upstream. Were you able to run git fetch upstream? Okay. Now can you try git branch again? Still the main is there? Guys, I'm told that we might need to wrap it up soon, so I'm just gonna quickly speed run the branch commands now. It's okay if you don't have it fully set up. We can work through that. That's not a challenge. But I at least want us to be able to write our first commit and set up our first repo, right? So what I want you to do is, you can learn about the branches later. What I want us to start looking at is the status, additions, and then viewing this, right? So let's actually look at this. But once we wrap this up today, you can still go through this repo, and the exercises are very self-explanatory. Start looking into them. I know that we spent a lot of time in getting the setup up and running, but it's good because now you know how this works, right? This is the toughest part. Like the rest of it is not too much of work. Of course, there is rebasing and merge conflicts, which requires, I would say like just some effort. But beyond that, the rest of it is, really like not too much of a challenge. Before we even do that, let's actually. So now that we have our repo, right? I've also created one more small exercise which you can go through later, which is essentially about when you want to start something from scratch, when you want to set up your first repo, how would you do that? Like right now, you've cloned an existing repo from open source. Most of the time, this is going to be your daily driver workflows. But when you want to start something from scratch, how do you do it? Is also present in this repository setup or the repo setup, folder for you to go through and try out that exercise. But instead of that, let's now just jump to this one, right? So now you can go into, let's just try to update the README file, right? So of the repo we just cloned, let's just try to update the README file. So now, if you look at it, you have this readme.md. I just want us to write hello world instead of git basics. Just change the git basics to hello world. And then I want you to, raise a PR. So now before we do that, let's actually first check out to a different branch. It's okay if you don't have all the branches. So let's just do a git checkout -b, and then I'm gonna say hello world. What this does is it's gonna create a new branch for me, which is gonna be called hello world. Okay. So now when I hit enter, I'm on the branch hello world. Now, how do I know I'm on branch hello world? If I do git branch, it's going to show that I'm on hello world. So whatever is highlighted is the branch that I'm currently on, right? Now, were you able to create the branch? Okay. Now let's actually do this, right? So let's just change this main readme from git basics to git basics hello world. Right. You can do a lot more, like you can essentially try any other changes as well. But I want us to go through this just for the sake of trying out the different commands. Now, if you look at it, if you're using VS Code, Git, because it has very good Git integrations, you should already be seeing a lot of the things here. So here, if you look at it, this is M, which means it's modified, right? And it's going to be highlighted in yellow. Now, for the sake of this, right, I'm just going to delete this repo setup.md. Okay. Now, of course, I'm going to restore it. But if you look at, and then if you come to the Git built-in extension, it's going to show that this was deleted. I'm going to just restore this, right? So now I just have only one modification. You can view the diff within VS Code itself. So here, if you look at it, this is how a typical diff looks like. So what this shows is which line was deleted and which line was added. Here, if you look at it, there was nothing deleted per se, but it's going to show red on the left side. So this is actually like a before and after snapshot. When you have like multiple changes, you'll be able to see the left-hand side and the right-hand side. And then you can review whether the changes are good to go or not. This becomes particularly important when you are raising pull requests. We'll go through that right now, but for the time being, this is the diff. You can also access the diff in command line. So you just do git diff. So my default editor is set to Vim, so it's going to show me this. But the way the diff looks like in a command line is not so pretty. You'll essentially see a unified diff, right? So it's not going to be a side-by-side diff. You can get it, like there are different Vim configurations and other configurations through which you can get a side-by-side diff, but this is essentially what it is. So the plus essentially indicates that a line was added, minus essentially indicates that a line was removed, right? So git diff is one part. Now let us say we are modifying like 6 different files or 7 different files. I've been working on this change for like multiple days and I don't know what all has changed. I want to know how many files have changed. So then if you do a git status, if you look at it, it says on branch hello world, changes not staged for commit. So there is something called a staging for commit and then the commit itself, right? When you add a new file by default, so let me also just add a new file, right? So I'll just say and I'll just create a file called touch hello world, .ps. I just added this hello world. Now let me do a git status. So if you look at it, there are two parts to this. One is the changes that are tracked by the system because README was already there. And then there's untracked files, which is essentially Git telling me that, hey, this is something that's new that I'm seeing right now. If you want to track it and if you want to version control this, bring this under your version control, you essentially do a git add. So you can do a git add hello _world.txt. So now if I do a git status, so it says changes to be committed, there's one new file, but there is one file that is not yet staged. What that means is you made a change, but before you commit, you want to tell Git that add this change to the commit, right? So you can do this. So when you say git add readme.md, it will add the modification also. Now if you do git status, it says, yeah, these are the changes modified, this is a new file, and this is essentially on hello world, and you can essentially have this taken away. And here you can also do restore -- staged and then file to unstage it. So if I do something like a git restore -- staged, and then because I don't want to commit hello world actually, so I'm just going to say hello world.txt. It's going to move it back to untracked. So now hello world went back to untracked. I know we are speed running this, but are you able to try any of these? Are you able to try any of these? Show of hands or thumbs up, thumbs down. Okay, cool. Yeah, so I'm just going to remove this untracked file anyway. So let's just do hello world, let's just remove it. Okay, so now I just have my change to my readme.md. Actually, now when I do git status, I know that this is staged. I'll show you how you can avoid doing the git add command and still directly be able to commit. Okay, so for that purpose, I'm going to just unstage this again. So I'll just do git restore minus staged, and then I'm going to say readme. Okay, so it went back to change is not staged for commit. It's modified. It's still tracked in the system. It's just not staged here, right? Now there are two ways to commit, right? Okay. So I just do git commit minus a. What this does is it adds everything into the system. And if I add an M key, I can add the commit message directly here as well. Or if I do git commit minus a, it's going to open my editor where I can say this is a test message, or let us say this is a test commit. And then if I save it, it gets committed. If I had done the same thing here with an M and then given my message in the quotes, even that would have worked the same way. Now, if you look at it, of course, I'm on hello world. Okay, so I'm just gonna push this to my origin branch, right? So what I do is I just say git push origin. So there's a command called set hyphen upstream, which is different from the upstream we discussed earlier. So this essentially is telling that set this origins, set this branch upstream to be in origin, set upstream, and then you can say hello world. Okay, so now what this did automatically is created a hello world branch for me in git basics PES. So here I already got the notification at the top as well saying hello world had recent pushes 11 seconds ago. And then I can just directly go here and then say compare and pull request. So I can essentially create a pull request directly from here. I know we are out of time, but what I would urge you to do is
We have 10 minutes more.
we have 10 minutes more? Okay, we have 10 minutes more. Okay, so let's talk more about pull requests then. So yeah, this is essentially the pull request view. You can modify how the pull request looks like. So you can essentially add comments here. You can block the PR from merging and all sort of stuff, right? So now you can essentially say ready to merge. You can, so there are, so when it comes to merge, always do squash and merge. I'll actually talk more about it, or maybe I'll share some things on the repo itself about what squash does, what rebase does. We have a rebase exercise in exercise 4 actually. Unfortunately, we didn't have enough time to cover it, but when you do get time, what I would urge you to do is start with, the repo setup. Like this is very useful if you're going to start something from scratch. Go through all the status add and diff commands. We essentially did most of it. We just didn't do the delete. So there are like different types of deletes that you can do. So you can do a direct RM or a git RM as well. So you can try that out. And then there are 4 simple exercises, right? So it's not very difficult. The first one is essentially for you to check out a new branch, and then push some changes and raise a PR, which we did right now. The second exercise is more around you trying to run the git rm command, and there are 2 variants of how you can remove a file from a pattern. And all of these are scenario based. So just read the scenario, try to understand in what situations you will actually see this happening. And then there's another one where, so we did try git fetch upstream, right? So the same thing you can do with git fetch origin. So when we like, because now you already have all your changes, it's all good. So you can do git fetch upstream as well, and then you can just do the check out important changes, and then you can try it out locally, right? And then the exercise 4 is more important, because now that you have John Doe's vacation, John Doe's vacation is essentially a thing where you will see merge conflicts that will occur when you try to pull, because you will have certain changes, and then main is ahead of it by some other conflicting changes where two people have done the same change, have done the change in the same file, but they are different changes. So now you need to essentially compare the diff at each stage. So you will go through an interactive rebase. I actually wanted to cover this, but okay. If time permits, what I'll do is I'll just record a quick video on or tutorial on this, and then I'll just update this here so that folks can follow this up, later. I'm sorry we couldn't cover a lot, but I hope this was helpful. Not really sure. Okay, cool then. Yeah, I'm just open for. I'm just going to leave the rest of the time open for some questions. We just have 5 minutes, but do you have any questions or anything that you wanted to talk about? You wanted to understand more? Any general stuff as well to say. You can even say like, yeah, I'm still okay with just doing v1, v2, v3 dot zips, and we can have a chat about that as well. But yeah, let me know. Yeah, go for it. Sorry. Yeah. Okay. Yeah. So, do you need to use Git? Good question. My question for you is, how long? What is the duration of your project? Like, how many days or how many weeks do you take on an average to do the project? 1 month. Okay. So let's say you're working on a project for 1 month. You're writing a piece of code. Of course, now with the advent of AI, half of it's nothing. I'm not even denying it. But even then, let us say you prompted something and there was a change that you made that broke something else, or let us say the whole app stopped working because of it. How will you get back to the previous version? No, I'm asking how will you get back to the previous version? Yeah, exactly, right? So it's doable. That's what I'm saying. So you can do it. Like, it's not at all a challenge. But if you keep doing that, you are essentially like managing multiple files, right? One is reverting it, but you're not even able to see the diff between what changed between v1 and v2. Can you do that with two different v1 v2 copies of the code? You can do it, but it's much more difficult, right? So, like, yeah, that's where this will help, because you can directly look in like a single browser window to say what changed between this and this that broke my code. And instead of going and reverting it and then rebuilding that whole feature again, you will just go and fix whatever is broken.
But it's like having to learn GitHub just so that I can use my code. It makes it more complicated what I do, because I don't know the commands, right? I first have to learn the commands, then I have to see what is breaking my project.
Yeah.
And then there's so many things.
Yeah, see, for your personal projects, again, it's totally up to you, right? But let's say 10 people are working on a team, which is how most companies operate, right? There's no single man, there's no one man company where there's just like, of course, like you can say that, with all the LLMs, you can run a one person company. That's what even OpenAI is running a challenge about. Like, there's a challenge for, who's the biggest revenue gainer, who has the idea, who can essentially build that company sort of a situation. But if you work in a team setting, you definitely need some sort of version control, primarily because it'll just be utter chaos if you don't have version control, right? It saves everybody a lot of time, if you ask me. Like, I don't know if you're still not, it looks like you're still not convinced, which is okay. But again, think about it, like V1, V2, how many versions will you keep? If, let us say, there's a company that needs to ship this to 100 customers, and all of them are paying customers who are paying us money. And I have a team of 20 developers who's essentially making changes. How do I know which version I ship to which customer? Right? All of that is a challenge. That is where version control helps, is what I'm saying.
How long does it take to actually learn all the commands?
You don't learn everything. So even I'm telling you with 10 years of experience, I don't know full game. So you learn what you require. Like when the situation arises, when you face a problem, let's say you face merge conflict, then you start learning about how you will do rebase and how you will resolve merge conflicts. Let us say you want to understand the whole history and diffs and how that whole history works. Like you can actually draw like a neat tree chart of the commit history. You won't need that unless you're essentially working in, you have the requirement of saying, give me the release notes for the last version to this version, right? Git is very powerful, uh, and don't get overwhelmed by it. You don't need to learn everything in one go. You just you get started, and then you'll automatically learn as you go. Like it's pretty much like every other craft in software engineering, right? So you don't learn all of C in one go. You don't learn programming language in one go. You don't learn how systems operate in one go or system architectures in one go. That's not the point. Git is just a tool at the end of the day. So see, like I said, right, Git is just one part of it. There are many other distributed version control systems like Mercurial, which also do a good job. And you might end up working in a team that is using Mercurial, which means that you will have to learn Mercurial because everybody around you is just using that. It all depends on your use case. That's what I was saying. Cool. I think we are on time, I guess. All right. Okay. Okay. Yeah. If there's nothing else, I think I'm good. I'll end my session here. I don't know if I've bored all of you here, but yeah. Thanks a lot. Cool, thanks. Shall I drop off?
Yeah, you can drop off the call.